So we take up examples on the big M method. This is an exceptional case of infeasibility. Infeasibility in the LPP. How does the big M method infer that the problem is infeasible? So let's say the question is maximize z equals to 3x1 plus 2x2, and the constraints are twice x1 plus x2 less than equal to 2, 3x1 plus 4x2 is greater than equal to 12, x1 comma x2 both are non-negative. So we convert this into equations. First is add a slack, make it into equal to. For the second, we subtract a surplus and add an artificial variable to make it into equal to's. The objective changes. 3x1 plus 2x2 was the original. We have added a slack. We have added an artificial. So minus m into a2 minus, because the problem is a maximization, so that is why we put a minus. The variables xi's are non-negative, si's are non-negative, a2 is non-negative, m is positive, tending towards infinity. This is for all I. This is for all I. So we make the table. So the table is CB, basic variable. The first variable is x1. So this is x2. Then we have s1, s2, a2, RHS, and theta j. So the coefficients are 3, 2, 0, 0, minus m, 2, 3, 1, 4, 1, 0, 0, minus 1, 0, 1, 2, 12. The basic variables are S1 and A2. So S1 and this is 0, this is minus m. Zj minus Cj is, the first value is minus 3m minus 3. The next value is minus 4m minus 2. This is 0. This is m. This is 0. Currently, we do not calculate z value. Now, for a maximization problem, this is a maximization problem. Most negative enters. The ratio is 2. This is 3. This leaves. So this is the pivot. It is already a 1. So S1 leaves and x2 enters. A2, x2 का coefficient is 2. A2 का coefficient is minus m. Pivot पहले से ही 1 है तो उस रो को कुछ नहीं करना. 2, 1, 0, 2. यहाँ पे बनाना है 0. अभी 4 दिखता है. So multiply this row by minus 4 and add. So minus 4 into 2 minus 8 plus 3 is minus 5. This becomes minus 4 plus 0 minus 4. This becomes minus 1. This becomes 1. Minus 4 into 2 minus 8. Minus 8 plus 12 is 4. So we calculate Zj minus Cj. What is the value? The value is 4, 5m plus 1. Next is 0. This is 4m plus 2. This is plus m. This is 0. Z value we will not calculate. See, the Zj minus Cj row has all non-negative values. This implies optima reached. But still, optima to reach ho gaya, but there is still an artificial variable in the basic variable column with a positive value, and we still do not have our Z value. So this condition is the condition of infeasibility. So what is the condition? So at the optima, if there exists an artificial variable in the basic variable column with a positive value, this implies the problem is infeasible. So the artificial variable basic variable के column में बचा है और उसका value positive है. This implies the problem is infeasible. See, if we wanted to solve this problem using the graphical method, we would see that the problem is in fact infeasible. So this is the LPP. So let's say we draw the graph of this. This is x1. This is x2. The first constraint, put x2 as 0. So what is x1? X1 is 1. So this is 1 comma 0. If you put this, so x2 is 2. So this is x2. So this is x2 0 comma 2. For the second constraint, put this as 0. So what is x1? X1 is 4. So x1 is 4. 4 comma 0. For this, put x2 is equal to 3. So x2 is in fact 3 0 comma 3. So the first constraint passes through this. The second constraint passes through this. The first constraint says that it is less than. So the region is and towards the origin. These two are non-negativity constraints, so we only have to care about the first quadrant. The next constraint says that it is greater than equal to. So the region is away from the origin because 0 plus 0 is not greater than equal to 12. So this is not satisfying. So since there is no common point, this implies the problem is infeasible. So that is what we get. Okay, there is one more thing. I mean, what is the significance of this artificial variable which has come out to be equal to 4? I mean, there has to be some significance also for this value 4. This 4 actually tells you that the second constraint, if we subtract this value 4 from the second constraint's right hand side, we will get a feasible answer. Let's say ये 4 आया था. Let's say we try to subtract this 4 from this 12. So what would be the value? ये 12 का बनने वाला है 12 minus 4. So ये बनने वाला है 8. Now what is the constraint? Now you see. तो ये constraint नहीं रहेगी. हमें change करना पड़ेगा. So let's change this and see what is the new region that we are getting. If we plot this, so x1 comes out to be 8 by 3. So 8 by 3 say this, comma 0. Okay. If we put this as 0, so x2 is now 2. So this point is again coming. Okay. So the line actually passes. So there is a common point now. This point is now common because this is the point where these two constraints actually meet. ये बोल रहा है इधर रहो, ये बोल रहा है इधर रहो, ये वाला इधर, ये वाला इधर. But इस point पे तो कम से कम meet कर ही रहे हैं. And what is that point? That point is 0, 2. There is only a single point. And what is that point? 0, 2. So this 4 or whatever positive value that you come, this 4, whatever is this positive value, क्योंकि ये second constraint में आया है, so अगर आप इस value को second constraint में minus कर दो, तो पहले यहाँ पे 12 था, अगर आप यहाँ से minus कर दो, so now you will start getting a answer. Okay? So that is what this, अगर ये artificial variable ऊपर होता, फर्स्ट रो में होता तो हम फर्स्ट रो से सब्ट्रैक्ट कर लेते. सो दिस टेल्स यू द अमाउंट ऑफ इनफीजिबिलिटी इन दैट सेकंड कंस्ट्रेंट.